Hi, welcome back. Thanks for again visiting the video. And we have gone through the lines and angles, and this particular video will be like a summary of whatever we have covered in lines and angles. And also we'll touch upon a brief history of geometry. Maybe it should be an introductory session. Instead of that, we are doing for a change in the summary. So even though great mathematicians like Thales and Pythagoras played a significant role, whatever the geometry we are learning are attributed to Euclid, who was there between 325 to 265 BC, and his book by name Elements is very popular, and he has written 13 chapters, 13 books, or I has to say, and he has used axioms, postulates, definitions, and theorems to provide whatever his feedings. So let's just go through these keywords and try to understand a little bit about them. We'll not be going in depth about them. Axioms are something like assumptions, which are self-evident truths, which you say something like sun rises in the east, and which are not specific to geometry, which are generic. And postulates are assumptions which are made specific to geometry, and the theorems are nothing but the results that are arrived by using the axioms, postulates, and definitions. And by the way, definitions are statements something like a line has only one dimension, and let me say something like and a point has no dimensions. These are all the statements, nothing but the definitions. What he did is he used the axioms, postulates, and definitions. He has found, or he has created some theorems. Now using that theorems again with again with the axioms and postulates, he has created more theorems. So in this way, he has created around 456 chains. So which is very mammoth work whatever he has done. So it should be we should actually at least spend couple of minutes to remember him for the great work whatever he has done. So that's about the Euclid, and we will move ahead. So what are the theorems that we have gone through in lines and angles? Understood that the angles will be formed whenever the lines are intersected with each other. We have seen two scenarios. The first scenario where the lines are intersecting with each other. When the lines are intersecting with each other, we have seen that the opposite vertical angles are equal. The theorem states that if two lines are intersecting, then the vertically opposite angles are equal to each other. That's the theorem with respect to the intersecting lines. Then we have seen couple of theorems with respect to the parallel lines. We know that parallel lines don't make any angles with each other because they're parallel, and they're not going to intersect because they're not going to meet at any point. But what we have seen is if two parallel lines are intersected by a transversal, nothing but a line which is intersecting both of them, then we have seen that the angles have relationship between them, and we have seen that the relationship exists between the angles. And what is the relationship we have seen? So the theorem states there are a couple of theorems. First let's go to the theorems which are with respect to the parallel lines. If two parallel lines are intersected by a transversal, then the theorem 1 states that alternate interior angles are equal. That means interior angles in this picture is 3, 4, 5, 6. Alternate interior angles are 3, 6 and 4, 5. So the theorem states that if two parallel lines, let me say this as L and M, if two parallel lines are intersected by a transversal, then the opposite interior angles 4 equal to 5 and 3 equal to 6. That's the theorem. And another theorem in extension of this is if two parallel lines are intersected by a transversal, then interior angles on the same side are supplementary. We have seen this already. 3 plus 5 is equal to 180 degrees. Similarly, angle 4 plus angle 6 is equal to 180 degrees. Now the next two theorems are nothing but the converse of whatever we have covered in these two theorems. Now in these two theorems, we have taken two parallel lines and we tried to intersect with another line, and we found the relationship between the angles. The next two theorems states that if there is a relationship existing between the angles, then the two lines are parallel. Now let us see what are those two theorems. If two lines are intersected by another line, if two lines like L and M are intersected by another line P, suppose, such that the alternate interior angles are equal. Let me repeat. If two lines are intersected by another line such that alternate interior angles are equal, then the two lines are parallel to each other. If two lines L and M are intersected by another line P such that alternate interior angles, in this picture 3 equal to 6 or 4 equal to 5, then the theorem states that L equal to M. In the similar lines, if two lines are intersected by another line such that the interior angles on the same side are supplementary, then the two lines are parallel to each other. That means 3 plus 5 equal to 180 degrees, then L is equal to M, or 4 plus 6 equal to 180 degrees, then L is equal to M. So these are the theorems what we have gone through, and we have applied this concept and solved some problems. Let me state that these videos are not replacement or an alternative for whatever you are learning in the textbook or in the class. These are just a little supplements or the initial first push to you, so that you understand the basic ground level concept, and then you can follow your textbooks and you will appreciate mathematics more. The idea is just to share the knowledge. So I appreciate if you can drop a mail to loveteachingmaths@gmail.com if you found that these videos are supplementary, which will give me encouragement to create more and more videos to help other students. Thanks for watching. Thank you very much. Bye bye.